Hey, what is up guys, and welcome back. So this is going to be part 2 of the basic flight controller PCB design based off of the Drone Mesh OpenFC project. Now all the files are linked down below. If you're curious how to get started, make sure you check the links down below. Also the playlist to the part 1 of this video, and as well as the links to how to get started on the project and how to access all these files. So we left off as we set up the microcontroller unit last time, which is this one right here. This is the F4 microcontroller unit. We set up a couple resistors, the Resinator, just everything that the flight controller or the microcontroller unit needs in order to operate, except we still have not applied power to this or grounded anything. And as you can tell here, we've also added our USB connector and this little Schottky diode. Oh no, this is a transistor here. This is where Sbus will be inverted before reaching the flight controller. And this will make more sense once we jump into the schematic and as well as the data sheets. And I'm keeping that for later because I don't want to lose people in the beginning. Right now, since all of the hard part is basically done and we've just tested it and it works perfect, it flew, then just, you know, all you need to do is just put this puzzle together and make your own flight controller. And then later on, if you really want to get into detail with this, just keep watching the playlist and I'll get into that details in later videos. Alright, so before continuing on, a huge shout out to our sponsor PCBWAY for sponsoring our open hardware flight controller. This is a great place to have your PCB manufactured as well as assembled with great quality and fast service. They also provide a 24-hour express service if you are in a hurry and want your projects in your hands as soon as possible. You can also check their shared project page if you're looking for some fun DIY kits contributed by other users, and they also hold a lot of events and some PCB contents which you could actually win cash prizes for. I do highly recommend you check out PCBWAY, and to check out PCBWAY, check the links down below. Alright, so let's get started. Let's see, what do we have left here? So as we can see here, we have our voltage regulator. This is the 3.3 volt regulator. We have our boot button. We have our little diode here, which will not allow the 5 volt from the USB and the 5 volt from the external source not to crisscross and create issues, which is the BAT54C diode here. We also have the 3.3 volt regulator we need to add, and we also need to add the gyro. So let's start with, let's go ahead and start with the gyro first. So let's bring in the gyro here. I'm going to bring up everything that the gyro needs, which is going to be underscore G. Okay, here we go. Do we need anything else? Here's a resistor for the gyro that's needed. LEDs, these are going to be together. The boot button, I'm just going to put it next to the boot button here. And I'm going to bring the voltage regulators and put them next to the voltage regulator just to make things a little nicer, and we can just easily start getting what we need. So let's take a look down here now. Now, we need to kind of take note of the orientation. If we set up the gyro like this would be pointing forward on the firmware. As you can tell, there's the slant here. And where you see the slant, this is where the dot would be on the gyro. The gyro has a dot in one of the corners, and you would have to, you know, go along with this little slash here or slant and not square. And in the build video, I think I showed you that when I built this. All right, so let's see, which way should we set up the orientation? You know what, let's set it up just like this here. I'm going to move it slightly away from the flight controller just to make our routes a little bit easier. Now I'm going to go ahead and grab the capacitors and just take a look. Okay, so this capacitor just is static to this pin here. And this one also same thing. I'm just going to set it up right there for right now. And we might move these also later on. Let's see if this one can jump around. This one has to be here for right now. So I'm going to set it up like this, I think. Yes, there we go. And this one, we'll set it up like this because these two are connected. Where is this one going? Ground. This one's going to VDD. Okay. So if that one's going ground, I'm going to set it up like this. And this resistor, where is this one going? Let's take a look. This is the Gyro CS. This is what initialized the gyro here, this resistor here. This is a pull-up resistor. And we'll get into the pull-up resistors and all these kinds of things later on. Now, you'll see how this actually works. Actually, you know what, let's take a look together, you know what. All right, let's take a look at this pull-up resistor here. So as you can tell, the Gyro CS pin that's going, we saw that little resistor, and that little resistor is going to go to VDD because when it wants to transfer data, it will actually open the line and create the pin to go high. And when you want it to go, basically creates a short circuit. And when we add a resistor, it doesn't create that short circuit because then we don't have the current flowing through, but we do see the signal going high to VDD, which is just, you know, high. That's how electronics speak. Either the power is off or the power is on. So high and low. And this is the way to enable the gyro here. And that's why we see that resistor. And again, we'll get into this in the later video. You don't really have to worry about it too much right now. Don't let it, you know, mess with your head, but you can always go research if you want, and if you always just wait for the playlist when we actually go into detail on this stuff. So I'm just going to put this actually a little bit further away. So let's start by connecting the gyro to the flight controller here. Okay, so there's gyro initialize. Let's see. We're going to grab our track tool or wire tool. Just want to see where this one goes. This is going to go all the way there. So what I'm going to do is I'm just going to set it up to go like this. It's going to be a really long route, but we really want to not block anything off. And you don't want right angles, but we're just going to let it pass for this one right now. Here we have another one. Okay. So this is nice. Okay. And here we have another one. These are to talk to the microcontroller unit. All right. So I want to see something real quick. I want to see what other pin goes where. So this one's supposed to go to that one, which is going to be a little bit difficult to get to, but we'll make a little trick to do that. Let's actually delete these. And you might have to delete things a couple times here and there. And it's something really normal just to kind of get an idea. And I want to make this, you know, as fast as possible for everybody. So that's why it's not really thought through on the design, but I'm just showing you the basics, and then you can put this puzzle together by yourself. All right, there we go. And where's this one going? That one's going there. And where's this one going? That one's going below it. It's okay. And I think that would be it. Let's just take a look here. Yeah, this one's going to go to the resistor. Okay, so all we have is this one here, and it's going, okay, so that one's going to go there. So let's set that up like so. All right. And this one was below. Okay. There we go. And what I want to do is I want to push away. Now we have to get to this one, but as you can tell, I can't because it's blocking my way here. So I'm going to push a little bit further away here, just to here. And I'm going to press the letter B. Or what you can do is go and switch to the second layer, and it'll give you the blue one now. But if you take a closer look now, if we get the blue one and we try to connect it, we're not going to be able to, because these pads are on the top layer. So once we get far enough away from any other trace that's on the first layer, then we can go back to the layers and click the top layer again, and then we can install it like so. And as you can tell, it created these oops, sorry about that. So what we want to do is set this up like this. That's not really nice either. All right, I'm just going to move this here. I don't know why I did that earlier. There we go. Perfect. Now we have everything connected. Now if you see these little dots usually on any PCB, it's usually just going from one layer to the next layer here. So what we did here was we went down, we went a little bit further away from these, because this will create a short circuit if it was close to one of the other traces. And we jumped to the bottom layer because it's a 2-layer PCB. We went under these two traces, we went a little bit further away, and then we created another via, which is to pop back to the first layer, and then we were able to connect to the pads, because you can tell they're red, that means the top layer, blue is the bottom layer. All right, so now the data lines are complete for the gyro here, and you can just start, modifying these as you please also. So we can just, do this, just make sure you don't get any right angles into this. I'm actually going to keep it a little bit further like this, because we might need to get these capacitors also. Don't forget about the capacitors here. So we're going to have this capacitor get connected there. And what I'm going to do, I'm going to bring it here. This one I'm going to bring up here. Okay. And these right there. Okay. So I'm just going to connect these two caps together. There we go. Just finished those. Now what I want to do is connect VDD, which is the power rail. And again, actually, I want to move this down slightly like so. And then now I can come in even better. So we're going to take this from the top layer. Make sure you have the top layer chosen. We're going to move a little bit further away. And then we're going to jump back to the bottom layer so we can actually jump over this. And again, we're not going to be able to connect it directly to the pad here because this is on the top layer. So we're going to have to go back to the top layer and then just set this up. There we go. And that's connected. Now we have power to the VDD, which is really nice. Or the capacitor is connected to VDD here. Now let's see what else do we need to connect. We need to connect this one, which should be very nice and smooth. Awesome. Okay. Now this one also we have to connect. So I'm just going to move it up a little. Can we put it in here? No, let's keep it out here. Okay. So I'm going to do the same thing. I'm on the top layer now. I'm going to press this. Just move a little bit maybe closer, just like that. And then I'm going to go ahead and jump to the bottom layer so I can bypass this line. And then I'm going to jump back to the top layer here, align it, and voila. So that's connected. Beautiful. All right, what else do we have here? Now we have the Gyro Select Pin. Now forget this VDD that it's going to this resistor. What that means is this is the VDD line. This is the 3.3 volt. They should all be connected, so you don't have to worry about that telling you to connect to this right here. Now, and because that's all just 3.3 volts basically, you can route them through anything. All right, so let's go ahead and connect the Gyro Select here, or chip select. So we're going to grab our wire tool, which is the track tool again. And we are on the top layer. Perfect. So I'm going to go just touch that resistor. I don't want to get too close to that via right there. Did you see this one? I don't want to get too close to that because I don't want to get an email saying, oh, it's too close to something. Now this side here has to be connected to the chip select pin. So we're going to have to come up here. Now, if you didn't have any room here, let me show you something. So we do have room, but let's just say you don't want to risk it, for example, and we don't have anything else to really connect. What we can do is we can go inside the middle of the gyro, just like this, and then drop to the bottom layer, and then we could just, you know, bypass everything here. So there we go. And we can just jump back to the top layer and have these connected. Boom, just like this. Now we have our gyro, I think, is 100% complete. Now, as you can tell, there's some sides I didn't connect, for example, the ground, because like I mentioned, I'm going to show you a little trick where it connects all the grounds, and it makes your life easier, and it also reduces, it's good practice, and it also reduces the production cost. All right, so we just finished the gyro. That was just pretty simple. Now, let's see, what should we do next? We're going to keep the LEDs because they're very simple. Just want to see what they're connected up here. So we're going to leave that for a little bit. All right, so now I'm going to bring in my 3.3 volt regulator, which is this guy right here. And I'm just going to switch them in to be like this. Now, you might say, what the hell is this here? Why is this there? You know, the top part. This is to keep it cool. So what you can do is create a special copper area for it, but that's for way more advanced video, and we really don't need to do it on such a flight controller here. So it's really not needed, and I'll get into that in a later video. So we need the VREG, we need the capacitor for VREG here to be as close as possible. It's always good to keep them as close as possible here. So right now, I'm not really just choosing a spot, I'm just bringing them in to figure out what I'm going to do here, because we need to run VDD to the flight controller, we need to run to its capacitors here, and we also need to run to the gyro here. So let's go ahead and take a look. Okay, so we need to actually flip this like this. There we go. And this one like that. All right, so VDD is 3.3 volts. So I'm going to run my first 3.3 volt to the capacitor that belongs to the VREG here. And this is for the 5 volt input that's going to be coming in, which we'll talk about in a later, in just once we get there actually. So now this is the 3.3 volt. This is where the 3.3 volt will be born for these components here, which is very important. Now, let's grab the VDD. Oops, okay. And we're going to give it to our first capacitors here. There we go. So now our flight control theoretically has 3.3 volts. And what we can also do is we could connect these pins together if we wanted to, like this. And now with the capacitors also here have a rail. Now it's really better if you run the wire directly to the caps also, which would go here. But we could figure out a way we can do that as well, is if we just make like a huge power line kind of thing going on for it. If you wanted to do that, you can just set up like a huge power line here, and then you can just there we go. You can also use the other layer, the bottom layer. Now these have all they have VDD, which means they have 3.3 volts here, so you can do that as well. We're just gonna keep it like that for now. All right, so now we also need VDD for that resistor that enables the gyro from the flight controller. So what we can do now is we can just grab VDD from here, and we can go give it to that resistor. And there we go, that resistor got VDD. Now our gyro needs 3.3 volts. So this is also the VDD line, as you can tell. And if you don't know, you can always zoom in and take a look, and it'll tell you VDD. All right, so what I want to do first is I want to apply it to the capacitor here that's connected to the gyro. So I'm just going to bring in a line here. There we go, that's connected, and that's giving the 3.3 volt through the capacitor to the microcontroller, the gyro here. Do we have any other VDD wires here? Nope, just this one, and we have it connected. All right, what else needs VDD? This will need 5 volt, and we'll explain why later. I think that's it, really. Yeah, that was it. We just gave power. So now all we need to do is give the regulator power, and we're gonna do that now here. Okay, so let's finish the what is it called? Let's go ahead and finish the LEDs here. So I'm just gonna bring them in. I'm gonna take a closer look here, and I'm gonna make sure. Okay, so this would be LED 2. As you can tell, it's connected here. This is a resistor, sorry, not the LED just yet, because the resistor goes before the LED. And the reason you put a resistor before the LED is because LEDs are suicidal. They will take all the current until they kill themselves. So keep that in mind, and that's the reason why you put a resistor by the LEDs here. All right, so there we go. And now let's just go ahead and grab those 2 LEDs here. Okay, I'm gonna just put it on this edge of the board, and this one at this edge of the board. There we go. And we could always move the writing here, so it'll make it easier for us, and we'll do that later on. All right, so let's connect them. Here's LED 1. There we go. Here's our LED 2, sorry. There we go. Now we've connected these. Now and again, we're not going to be able to go straight across to this LED. Just making sure the pads are correct. So what we can do is just move up slightly, and then we could drop to the bottom layer, and then go up more, just like this, and go back to the top layer, and we're connected. And we can do the same thing for this one. Just make sure you don't get too close to anything. As you can tell, I'm keeping safe distance. Perfect. Oh, nope, that wasn't perfect. You know why it's not perfect? Oh, it should be perfect. Okay, because this was not connected. That's why. Uh-oh. We deleted the whole resistor. Okay, so I'm just going to delete these. And there we go. We're going to have to edit the bottom layer in order for us to access the this one. There we go. Okay. So I didn't set up the link correctly here. All right, so again, we're going to go to the top layer. We're going to run our wire. Okay, and I'm going to drop to the bottom layer again. And right here, I'm going to go back to the top layer and connect my LED. Now this side of the LED is connected to ground, and again, we're going to connect all the grounds later on with a very simple step. All right, so let's take a look at what we have left now. We have the boot button as well as the resistor for the boot button, and we have this diode here. And if you've watched how to fix a flight controller, usually this is the thing again that will burn first, which will, if you plug in a USB and there's no power for some reason, but if you put in the battery in your flight controller and it works, it's because of this guy here. So let's take a look at this guy. Where are we going to place him? We're going to put him, I think we'll just stick him right here for now. And we're going to need, we don't need anything else actually. All right, so what we want to do now, this one will take 2 5 volts, and it will, what it'll do is it will output 1 5 volt here. So hold on, give me a second. I'm just trying to figure out where's the best place to set this guy up, just to make it a little bit easier for us. Okay, so I'm going to put the Schottky diode right here. And this again will take the 5 volts from the USB and 5 volts from the external source and only allow 1 to go through. And through this diode, the 3.3 volt regulator would get its 5 volts, whether it's from the 5 volt from the external source or whether it's from the USB here. And the way we want to do this is we're going to take this. This will be the outputted 5 volts. And we're going to go ahead and drop it into our voltage regulator. And now what we can do, or what we have to do, is bring in a separate 5 volt. So this board will be powered from an external 5 volt. So we'll create a 5 volt pad out here, or a 5 volt input pad, so we can power everything up, because it'll go to this and it'll go to the regulator, and this regulator will give everything power basically. So we're going to leave the pad for later, but now we need to add the USB, the 5 volt from the USB here. So we need to route one all the way from this right there. So let's see, where is this going here? 5 volt USB. So we can actually take from this right there. So what we can do is we can just zoom in. This is, again, 5 volts from this right here. So I'm just going to take it from here right there. It's very important to take it from there. Okay. Let's just take a closer look, and I'm going to go here, and we're just going to say, we're going to go through here, and I'm gonna drop to the bottom layer. I pressed B, just makes it a life easier. And then now, but I can't go back after press the top layer, and I'm gonna go ahead and connect it. So now this has 5 volts from the USB here, and we should probably put these things on the other side, but that's totally fine now. And now we also need 5 volt to power this whole board up. So the way we do that is just like this. So we need 5 volts. Okay, so it's called 5 volt, and if we click on it, we take a look at the right, it says net 5V. So what you want to do is you want to go to the pad here from the PCB tools, and we're just going to just drop one right here. We're going to click on it after we set it up, and we could change its, you know, its settings here. So I'm going to say rectangle, I'm going to say top layer, and you could choose its size. Currently it's mil, so if you want to press on the black part here, and we're going to change it to millimeters, and I'm going to click back on it, and I should get in millimeters here. So I want to make this 2 millimeters by 2 millimeters pad. There we go. So this is a 5 volt pad, but it's not yet 5 volt, because what we want to do is we want to connect them together. But if we try to connect them together now, it won't let me. Can you see that? It's not really letting me. So why isn't it not letting me? Because you have to specify that this connects to this. And how do you do that? We click on this pad, and as you see where it says net, it says 5 volts. So I'm just going to take a copy of this here, and then I'm going to go ahead and click on this one, and I'm going to go to the net. You see how it's empty? And I'm just going to add the net right there, and now it should allow me to connect it, as you can tell. So let's just say boom, there we go. Now we've connected. So this would be 5 volt from an external source that will give 5 volts to this diode, or it'll also take 5 volt from the USB right here, and it'll output the 5 volts to the 3.3 volt regulator, any one of these two, and then we'll power everything up through this regulator. So that's the only thing that diode acts. All right, now let's go ahead and jump to the boot button here. So we can just take a look here, and here's the resistor. Now let's take a look at the boot button. The boot button, basically what it does, all it does is it makes, hold on, which one is it? I'm just trying to figure it out real quick. Okay, so it just makes one of the pins on the flight control, which is I think this one right here. It's usually low. That means there's no volts in it. And when you press the button, what that does is when you press the button on the boot button, it will short circuit to 3.3 volts, so it'll make it high. But if you do that, you obviously short circuit the microcontroller unit, and that is why, again, we add a resistor. So we don't short circuit it, we limit the current, and all it says, oh yeah, I did get the 3.3 volts, but there was no really bad current going through that short circuit in order to fry your flight controller. And that's why you need these this little resistor here. So let's take a look at how the resistor is connected. Okay. So let's go ahead and connect this resistor now. So we're going to need this one here. I'm just going to bring it in like so and drop it in. There we go. And now where does this go? VDD, VDD. So we need to give it VDD, which we will do in a little bit. VDD is 3.3 volts. And this one right here is connected to that resistor there. So we're going to have to drop to the bottom layer to connect this. Okay. So we can bypass that line. There we go. And now I'm going to drop again to the top layer. There we go. Now VDD. And these two are connected also, so you can connect these. There we go. And where's VDD line? We can grab VDD from here, I think. Yeah, here's a VDD line. So we can just go along with this. Oh, and actually this was a VDD line too. How do you know that? Yeah, this is a VDD line. So we can just grab this and boom. And we could also do this if you wanted to. There we go. Awesome. Now our boot button is done. So if you're flashing this for the first time, you have to press the boot button to flash the Betaflight firmware. All right, so now we have our PCB basically 90% done. All that's left for us to do is add the pads and the mounting holes and the ground, and we're done. So it's really nice. Now let's go ahead and start with the pads here. I don't think I'll get into all of the pads. We'll just do a couple together. We'll do motor 1 and 2, and we'll do Sbus, so you guys can see how Sbus is connected. And we'll do probably Uart 2, RX and TX. All right, so first things first. Now 5 volt that's going to be inputted into the board here also needs a ground. So first we're going to have to set up a new pad. So what I like to do is I'll grab this pad, copy it, paste it, and then we'll say here's a new pad. But what we have to do next, we have to click on this, go to net, and in capital letters put GND. So this will later on, the system will know to connect all the grounds together. And that's it. Now this is a ground pad now. This is very important. And to do the writing, so you'll know, and I recommend you do these as you go actually. So this is a 5-volt in. So you want to go to the top silk layer, because we are working on the top layer. You want to click edit, and then we go to the text icon. And then we could press space bar. You could change it however you want. So I'm going to set it up like this, because it's going to be upside down, or just like this is fine too. There we go. And I'm going to put this one also. So we're going to say this one is GND. We could change the size also, and we'll call this 5-volt in. This actually takes up to 12 volts here, but we're just going to say 5-volt in. 5-volt input. There we go. You don't have to make it that big. Obviously, you'll know your own key codes. I'm just going to keep it in. It looks better. There we go. Oh. Ah, god damn it. There we go. Oh my goodness, what the hell's wrong with me? All right. There we go, 5-volt in. And if you want to change the size of this, you just click on it, and I'm going to say line height 1.5 millimeters. There we go, line height 1.5 millimeters. You can go even lower if you want. So now we know that when we're going to make the board, this will be 5-volt input for the board, and this would be the ground. This would power up the whole board here if you weren't powering it from USB. So these are really important here. So here we have LED 1. Everything in yellow will actually be printed on the circuit board. Now make sure you always double check where you're editing, what layer you're editing. Currently we're still on the top silk layer here. I'm gonna go back to the top layer now. Okay, so I want to add my signal pads, my motors. So I'm gonna add, oh, here's motor 1 and here's motor 4. As you can see, S1, S4. So let's go ahead and set those up. Where should we put the pads? It doesn't matter. So I'm gonna grab a pad again. I'm just going to put the motor 1 and like motor 1 through 4 here. 1, 2, 3, and 4. You could add ground if you wanted to. It's up to you. I'm just showing you the basics right now. Now, if we zoom in, it's all says ground, and we don't want that. So we want to click on the first one and put S1 like we saw over there. And then here we're going to put S2. That's how I named them. Here we're going to put S3. Make sure it's capital. And then here we're going to put S4. So motor 1s through 4. Perfect. Now let's take a look at motor 4. So this is motor 4, and we're going to have to connect it. So let's go ahead and grab this, and we're going to go here. Now we're not going to be able to go through, so we're going to have to go to the bottom layer again. And let's go ahead and bring that up. As you can tell, we're not going to be able to cross here. So I'm going to drop it right here and then go back to the top layer. And then this was, what was this? Motor 4. I'm going to come in on an angle because motor 4 is there. Okay. And I'm going to connect it. Boom. There. Now we have motor 4 connected. This is motor 1. All right. Awesome. Let's go grab motor 1. So I'm going to bring it in right about here. I'm going to drop down another layer. And we're not going to be able to cross that one very cleanly. So what we can do is we can stay here, jump back, which is very inefficient, but just for the sake of the review here, or the video. And there's motor 1 connected. So now I have motor 1 and motor 4 connected, and motor 2 and 3 are the same process. You can do them through here. I'll show you a little nice trick. So as you can tell, oh my god, how am I going to get there? But we kept the insides pretty much empty. So we'll do just one of these. So we're going to go to the top layer. We're going to move up slightly. Now these pins are not going to be connecting anything, so we're pretty much safe here. So I'm going to go here, and then I'm going to drop to the bottom layer, and I can go through everything here, as you can tell, which is really nice. And what did we say? What motor was that? That was motor 2. So let's see. Motor 2. Okay. So we can just go all the way to here. Actually, we're going to have to probably go twice. So we're going to go here, jump back to the first layer, cross this one, and then jump back down to the other layer, go here, and then we're going to jump back down, and there we go. Now we've connected motor 2 here. Motor 3, we'll leave it for later. Now let's go ahead and do a Uart, I think. Yeah, let's set up a Uart here. Let's do the Uart, then we'll jump to Sbus. I think it'll be easier. So here we have Uart 3 RX and Uart 3 TX. Okay, sounds good. Let's add 2 pads. Here's a pad, and here's a pad. Okay, let's zoom in. actually, before we zoom in, let's actually go to the pad of the Uart. So that's very important. So we want to click on it. So we're going to do Uart 3TX. You want to click on this, find the net, which is this one, and copy it. So just Ctrl C, copied that. And I'm going to go to one of the pads that I've created, which is going to be this one. I'm going to go to net and I'm going to paste that. So now that is Uart 3TX pad. Now let's go grab the RX pad, which is this one. Again, I'm going to click on it, get the net, not the name, the net, because sometimes the name does pop out. I copied it. So this is the RX. We're going to go to the other pad that I've created, go to the net, and just paste it back in. There we go. We have RX and TX. And let's add some text. Oh, you see this? I just made a mistake. Don't add text when it's red. That's not good. We have to go to the top silk layer, and then we're going to press the text icon. Okay. So I'm just going to make 2 of those. All right. So we're going to say RX6 and TX6. Was it 6? No, it was 3. Shit. Okay. Just double click, you can edit it, which is really nice. 3. Okay. And let's make them smaller. Line width, line height. I'm going to make them 1.1. That's better. And here we go, 1.1 millimeters. Okay. And this was, let's double check. Yeah, this is RX3 and this is TX3. Beautiful. Don't forget to add a ground and a 5 volt if you wanted a 5 volt here, if you're using iBus or something. So to keep that into consideration also. So now this is a little bit tricky here. It's gotten a little bit hectic in this area. And let's see, what do we want to start with? We're going to start with the TX. Yeah, let's start with the TX here. All right, so I'm going to drop in the TX. Oh, we have to go back to the top layer again and grab our tool. Here's the TX. This is Uart TX3. Let's just call it TX3 for now. I'm going to zoom out here just slightly to see where I'm going. Okay. So I'm going to go about here and I'm going to drop to the bottom layer. And then I can just jump through everything. There we go. And about here, I'm going to drop back to the top layer so I can connect it. And we're connected. Beautiful. Now let's grab our Uart, the RX3 here. So I'm going to do the same thing. Make sure I'm spaced a good distance away from these 2 lines before I jump to my bottom layers via, because the vias also can be pretty big. So there we go. Right here. I'm going to drop back to the top layer and boom. There we go. Beautiful. So now we have a TX3 and RX3 here. All right, so that was pretty easy. Now let's set up Sbus. Now Sbus, again, for the F4s has to go through this transistor because this is what will invert the signal. This is why I say, oh, it's inverted or uninverted. If most of you probably already know what that means, but if you don't know what that means, this is what we need in order to invert the signal so the flight controller can understand the Sbus signal. All right, so let's go ahead and set up our pads basically for the Sbus here. All right, so what we're going to do now is we are going to put a new pad. We're going to say this is going to be Sbus, and this is going to be ground. So we're going to click on the one that we want to be ground. Go to the net. The nets are very important. Put G and D. All right, that's good. And this one is going to be Sbus. Now we're going to go find Sbus. Sbus is not going to be connected on the microcontroller here. See, it's on Uart 1, and it goes to this. Where is it? It goes to this resistor. Which goes to this transistor, which this transistor goes to another resistor, which the other side of that resistor is connected to Sbus. And what these resistors are doing here is so it doesn't create a short circuit, kind of like the gyro thing. It just inverts the signal. So if one was going 0, or if for example, if Sbus wanted to send the letter or the number 1 to the flight controller, it would probably be 0 volts. But the flight controller cannot understand 0 volts. It only understands if you speak in 3.3 volts or something. So that will just invert it. It just inverts the signal. And no, we'll get into that later on. I just don't want to lose you right now. All right, so here is Sbus, as you can tell, on this resistor. So we're going to go to the net, and we're going to grab the Sbus net here. And we're going to go to this pad, because we're going to make this pad the Sbus. I'm just going to paste it right there. Awesome. Now we're just going to connect them. So grab my track tool, or you can press W. I usually press W. I'm going to go here, drop to the bottom layer, go here, drop to the top layer, and go there. There we go. And and like this, we have our Sbus. All we need to do is just write Sbus in ground. So I'm going to take a copy of, I just clicked on this one. I'm just going to take a copy of it, the same thing. You can just Control C, Control V, and press spacebar, and you can flip them. All right, I'm just gonna say this is ground, and this is Sbus. Now, for the sake of the tutorial, so I don't take a trillion years to complete, this is the reason why I did this in the first steps. Because later on, I want to when I make the board smaller, it'll be easier for you to see. It'll be easier for you to understand. That's why I made it so big, so we can kind of get an idea of how it's working. So here we have a pretty basic board, kind of. We don't have our motor signal 3 connected, but you can figure that out on your own. And I think I gave enough of the basics for you to kind of get an idea here. And obviously, we're going to get more advanced, and then we'll get into more detail as time goes on. Now what we want to do is, let's just say we wanted to add mounting holes. So you want to go for it. You want to find this one where it says hole here, and then just place it anywhere currently. Once you place it anywhere, press the escape key so you can, just not be doing anything. So you can click on this. And if you take a look, here's the hole D, which means the diameter. Obviously, most of you want it 4 millimeters, so you can incorporate your rubber grommets. And there we go. That's a 4 millimeter hole right here. And we could just Control C, Control V, put another mount right there. Here we go. This might work on a wing if you wanted to. And you can set that up as you please here. Now, if you wanted to measure, all you have to do is press the M key. If you press the M key, then you can get a pretty good measurement here. And with the, so there we go, M key. And when you scroll, you want to scroll like this, not with the middle button or the scroll wheel. You want to do it with the right click. So you hold it and you move it, and this way it won't lock whatever you're doing. So if we zoom in closer, we see on the bottom right there, it tells us the length is 78.74 millimeters from hole to hole. So this is how you would measure your 30.5 by 30.5 mounting hole, because that's how they are. This is the OSD version. So for example, if we take the middle of this one and we go to the middle of this one, we should get 30.5. That's correct. 30.48, which is perfect. So that's how our flight controllers are made. The hole from the center is 30.5. Keep that in mind. 30.5. 20 by 20 is obviously 20 by 20. Even though we call it 30 by 30 stacks, it's actually 30.5 millimeters from the center of the hole. So keep that in mind. All of them, even from the top to the bottom to the left. So it's the same thing. This one's maybe a little bit larger here. Oh, it's perfect. 3.5 also. So yeah, keep that in mind. That'll be very useful for you. All right, guys. So now we have to add ground to the board. Now we're gonna have to add it to the bottom layer as well as the top layer. And what we can do, we don't have to actually add it to the bottom layer, but it's really nice if we do. Now, if we take a look here, there's nothing linked to ground on the bottom layer. So what we can do is grab one of these ground pads. I'm gonna grab this one here. And I'm going to go to, as you can tell here, you can see top layer, bottom layer, multi-layer. I'm going to set it up as a multi-layer. There we go. Make sure it's a ground pad. So there we go. We have a ground pad. Now we want to do is go to the bottom layer and go to this one here. It's called the Culprit area tool, I think. Culprit area, yeah, this little dotted one. And you want to just go ahead, click here, click here, click here. And on the last one, you don't do a normal click, you do a left click. And then you get this here. And then you want to do the same thing. You want to go to the top layer and you want to do the same exact thing. Click here, click here. Just make sure you're outside the board. And then the last one, a right click. Boom. There we go. We have our own flight controller, which is ready to be manufactured, even though it has one TX and RX and it just has a 5-volt in and it has no 5-volt output. But we have a working flight controller. Actually, here we forgot to, as you can tell here, we forgot to add which motor is what in the text. So let's go ahead and grab those. I'm just going to copy this. I'll zoom in. So I'm going to put one here. I'm going to put one here. I'm going to put one here. And I'm going to put one here. And we're going to say S1, which is motor 1. S2. And it's just like a puzzle. The more you practice, the better you get at it. And when I did the OSD version, I had to basically start over around 20 times until I got it. But I stayed persistent. I stayed a good 12 hours straight on that thing. I actually forgot to eat that day. But yeah, just persistence. You'll do anything, really. Just be committed and you can do it. And we still have a lot of real estate on this board. Now, for example, if you really just wanted it now, I would highly recommend you add a little bit more to it. You can go ahead and order it. And I'm going to show you how to order it as well. But before you do, if you want to take a look at how this board is going to look like, just save it. So Control S. And then we can go to the picture here and say 3D view. Let's take a look at it. I'm curious to see how well this is going to look in 3D mode. or how it's going to look in 3D view. You can also even change the color and stuff, so you get an idea. So here's blue. I like them blue. And yeah, the board looks really clean. It looks really nice. Let's take a look at the back side here. We have to turn it out like this. There we go. So this is the back side. Absolutely empty. And yeah, 5-volt in, ground, motors, TX3, RX3, ground, Sbus. And if you're more advanced, you could remove all of these and arrange them so you know what is going to go where through the BOM list, bill of material list. Which again, if you don't know this stuff, just make sure you watch every single video of the playlist and you'll understand how this project works, and just watch the links down below. So now, for example, we wanted to go ahead and order this. You wanted to order it for some reason. Where is it? Here it is. So make sure you have both of these layers, as you can tell, the copper area, because that's gonna, you just grounded everything without having to connect grounds here. Just double checking here. Oh, we didn't give 5 volts. Did we give 5 volts? No, we didn't. All right. So the Sbus inverter, as you can tell, we actually forgot to do something here. We forgot to give it 5 volts. So we're going to have to go back here. I'm just going to erase, you have to erase these if you're going to do a modification. So we're going to have to give this resistor 5 volts here. So the Sbus inversion will actually work. So I'm going to go back here. I'm going to drop to the bottom layer. And let's see, where can we go? We can go up here. There we go. And 5 volts, I want it to be on the output rail, which is going to be on this one, on the 5 volt output. So we're going to drop to the other layer. There we go. Or you know what, that's fine. We can just set it up to the 5 volts here, because anyways that's going to be powering it. There we go. Now we just gave 5 volts to that resistor that will invert the signal for Sbus. And what we can do also here, as you can tell, VDD, we can give those power also. You can just connect them like this, and then this is also a VDD line right here, so we connect it here. And yeah, and here's also another VDD line, which you can also connect like this. So now all the VDDs are even connected. So now we have nothing else to do here. So what we can do is go back to we'll start with the bottom layer, go to the copper area tool, and again, click, 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 and then a right click. Top layer, same thing, click, 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 and a right click. All right, now the board is done. We can save it. And what we do is we go to this G here, and we can say check for any errors. Theoretically, we shouldn't have any errors. We don't, as you can tell, 0 errors here. So what we can do now, all right, now to order, again, you click here, generate Gerber, and just click download Gerber, and that's it. And then you just upload it to PCBWAY and then just have it done, which is really nice, as you can tell. So it just downloaded the Gerber files, and this is what you will upload to PCBWAY to make your order, which is just simple. And if you didn't know how to do that, let's go ahead and take a look how to do that. All right, so you obviously, first thing you want to do is you want to go to the PCBWAY website, and then here we're going to say 2 layers. Thickness, just leave that default. Put 10 pieces, because 5 and 10 pieces are always the same price. And we're going to go back to our board here, and let's quickly get its measurements, because we don't know. So we're going to see its current, what is this would be called? This would be its width here. So if we just measure it, it's around 86.10 millimeters. You can see that on the bottom right there. If I'm moving it, you can see these numbers change. So its length is 86.10, so I'm going to put 86.15. So I'm going to go back to here. So I'm going to put length or width 86.15, and its length is, let's see. So we're going to do its length now. So we're going to click M, and I'm just going to measure it. It doesn't have to be perfect, because these actually show up in the files when they go make them, just somewhere close. So we're just going to say 53, because it's 52.82 millimeters. So I'm going to say 53. All right, so 53 millimeters. Quote now. All right, and again, just leave this default, 10 pieces, everything default. Here you could choose the color, so you can choose whatever color you want. I'm going to choose blue, and we're going to say household lead. Now this is very important. Oh no, not this one. Okay, so that's good. Everything looks great. So it will cost us 25 bucks. Well, at least me, but it's actually $5. And if you use the links down below, you can get it for free and basically just pay for your shipping. And you can change the shipping. There's cheaper ones, there's even more expensive ones, so not 12 bucks, but it just depends on the shipping cost. So you know, it just depends on the shipping again. So whatever country you have, obviously have different prices. So it just costs $5. And if you were to change it to 5 pieces, it'll still cost the same thing. So just get 10 pieces. All right, and if you wanted to, I highly recommend you get a stencil. It's the thing where you can put over the board and you can just drop the what is it called, the solder paste, so you don't have to put, you know, solder paste on every single pad. You just align it and then just, you know, just bring in a squeegee or something and just, you know, drop that solder paste and it fits in perfect. And you just click on that and just order it with it. It's around 10 bucks or 15 bucks extra, but it's well worth it if you're going to be building 10 of them or something. And yeah, and that's it. You just say add to cart. You just sign in and you just upload your files and you're good to go. That's it. It'll give you a upload box. You upload it and then it'll give you it'll say pending. They'll do a review and then they'll send you an email, say okay, it's passed. Now you can log back in and just press checkout, which is really nice under my orders. And well, that's it, guys. I really hope you guys enjoyed the video. We're gonna go a little bit deeper next time. We'll do a 30 by 30. It's gonna be a little bit more complicated, but anyone who decides to go ahead and make their own, even if it looks like this, even if it's like just you know, it's not really fully developed or it's your first PCB, please add it to the drone mesh forum. I would really love to see it, and I would also really love to help. As soon as I see I have some time, I'll really jump in and do some modifications with you, or just give you some helpful tips and hints. And also I'm sure other people hopefully will also do the same. And well, that's it, guys. I really hope you guys enjoyed the video, and there's gonna be more of this stuff, and this is just the first intro here. I really hope you guys enjoyed it. If you guys think I need to change something in the way that I'm making these videos or the way that I'm teaching them, let me know down in the comment section, because we still have a lot more to go through in this playlist. This is just a basic setup here, just to get someone I just want people to start playing around with it right now and try to make their own boards, which would be really nice. And then later on, things will even make more and more sense as we go along. And well, that's it, guys. I hope you guys enjoyed the video, and I'll see you in the next one. Peace out.